everyone. We're live right now.
Okay, thanks. Thanks everybody for being here with us today. This LAERE-EfD Seminar. We are very happy to have with us Ariaster Chimeli. I'm not sure if I'm pronouncing right your last name, but I apologize for that. But Ari has a bachelor degree in economics from the Federal University of Minas Gerais in Brazil, and a master and PhD degrees in economics from the University of Illinois at Urbana-Champaign. He works currently as full professor in the Department of Economics at Universidade de Sao Paulo in Brazil. And prior to moving to USP, Ari was a postdoctoral research fellow at Columbia University, the International Research Institute for Climate and Society. And he was then an assistant and associate professor at Ohio University. And Ari works on research on growth and environment, climate, tropical forests, energy, international trade, and water and extreme events. As I said, we're very happy to have Ari with us today. Just briefly, let me mention that Oscar Melo, who's from Universidad Católica de Chile and is part of the LAERE board, as he's the treasurer of LAERE, he will be the moderator of this seminar. So the idea is that Ari will have the floor in just a couple of seconds. He will present the paper. If you guys have some pressing questions, some clarifying questions that need to be answered while Ari is talking, you can let us know in the chat, and then Oscar can tell Ari. If not, the questions will be at the end, and Oscar will be helping us again to manage the order of the questions. If you want, you can. No, it's easier if you once Oscar tells you, you can unmute yourself. Hopefully turn on your camera and then ask your question to Ari. So I have nothing else to say. Just Ari, the floor is yours.
Thank you, Alejandro. Thank you for having me here. I've been following some of your talks, and I'm really glad that you're promoting this. I've been learning quite a bit. It's an honor for me to be here talking to this audience. So let me share my screen here, and I guess everybody should be able to see this by now, right?
Yes.
Great. Okay, so this is joint work with Thales Rosenfeld. He's working here in São Paulo at the ICCT. And what we do here is we look at some water supply policies that were implemented in the city of São Paulo in Brazil, following an important drought that we had here in 2014, 2015. And we look at the health consequences of these policies. So to put things a little bit in context, we have been experiencing extreme events, and the forecast with climate change is that this is going to become more frequent and possibly more severe. And we have seen a lot of work that is exploring the linkage between climate change and extreme events and the socioeconomic impacts that these have. In our particular case, we're going to focus on a large urban area. It is very often we do see some of these studies, and many of them focus, for example, on large rural areas. Our focus here and our contribution to the literature is to have an additional study on a large urban area. That's where most people in the world live, urban areas. And we think it's important to look at possible impacts of climate variability and climate change in these places. In particular, we're going to be looking at an urban area with a very large water supply system and a very robust water supply system. This supply system is in place for decades, and we hadn't had any problems, any major problems until 2014, 2015. And unfortunately, this topic is very timely because once again, we are about to have another water crisis in Brazil. When we had this crisis in the city of São Paulo in 2014, this was the worst crisis in 80 years. Now we are about to experience the worst drought in 90 years. So it's supposed to be even worse than what we had. The system the water supply system in São Paulo has become more robust after that crisis in 2014, but still this problem can occur in other cities in the country and in other parts of in other cities in the world. So what we're going to do in particular in this paper is to look at water supply policies to cope with that large major drought in 2014 in the metropolitan region of São Paulo. Okay, just to put things a little bit in context for those of you who are not very familiar with São Paulo, it is home to about 20 million inhabitants. That's the metropolitan region. So this is about 10% of the Brazilian population, and about 20% of the Brazilian GDP is produced within this metropolitan area. So it's a very important area for the country, both in terms of population and in the national economy. And as a response to the 2014-2015 water drought, we had some important policies that were implemented. They were emergency policies. They required a quick response to what was going on. And we're going to focus on two major policies. There were other policies that were implemented. I'll talk about those in a minute. The first one we'll talk about here is the water pressure reduction policy to avoid losses in the system. What happens is that a large percentage of the water that is distributed to the city is lost in underground cracks in the pipe system. And the idea behind reducing water pressure is to reduce these losses. And this reduction took place, and it still takes place actually, mostly at night. But it also took place during different parts of the day in 2014 and in different parts of the city. The other policy that I'm going to discuss here is the use of the technical reserve of the Canterra reservoir system. What was the idea here? There are 8 reservoir systems that supply water to the city of São Paulo. The Canterra system is the largest one. And that was the one that was the most severely affected by the drought at that time. And what happened was that the system has a so-called technical reserve. It was also called by the media by the dead volume, which made things worse. And what happens is that this technical reserve is below the level of the collection pipes, of the water collection pipes. So in order to use water from this part of the reservoir, you have to pump water up first, and then when it reaches the pipes, it is distributed to the rest of the city. And there was a lot of concern at the time that the use of this water could be problematic. Nobody had ever used that water, and there was the suspicion that that water could be of lower quality and it could cause diseases. The water company always defended that it was not the case. It was good quality water, and they had no choice. They had to use that water. So we're going to look at these two policies: the water reduction, water pressure reduction, and the use of the technical reserve of the Canterra system. And we're going to see if there was any association with these policies and the incidence of fecal oral diseases. And we are also going to pay attention to defensive behavior that the population might have adopted during that crisis and as a consequence of these policies. So very quickly here, our paper communicates with two streams of the literature. One of them that associates water quality and water quantity with health. A lot of the studies that were conducted look at, again, at rural areas, and they estimate long-term impacts on economic development and welfare. So we're going to contribute to that literature, but now focusing on a large urban area. Again, the importance of that is that's where most people of the world live. Another stream of the literature looks at defensive behavior. There are classical contributions by Nigel and Jeff Graf-Ziven, and they call our attention to the fact that we need to pay attention to defensive behavior if we want to qualify the impact of pollution on health. Janet Curry has some work as well, and we are going to find some evidence that this is actually taking place here in the city of São Paulo. Just to give you a sense of the results, to anticipate them, when we look at the pressure reduction policy, we do find an impact, an effect, an increase in hospitalizations, especially in lower income neighborhoods and for the very young and the elderly. Okay. Again, we're looking at hospitalizations due to fecal oral diseases. When we look at the supply of water from the technical reserve of the Canterra system, we do not find an increase in hospitalizations. Much to the contrary, we estimate a decrease in hospitalizations due to fecal oral diseases in those areas, especially in low-income areas. We argue that this is most likely due to defensive behavior that was adopted there. We highlight the fact that the use of water from that system, from the dead volume, from the technical reserve, was very salient in the media at the time. Okay, so again, the metropolitan region of São Paulo is home to about 20 million people, and it encompasses 39 municipalities. Sabesp is the company that supplies water to 35 of these municipalities, so to most of the population that lives in the area. It counts on an integrated system of 8 reservoirs. It's actually a system of 8 reservoir systems that are, some of them are interconnected among themselves, others are not. The Canterra system is the largest system. That was the one that used water from the dead volume, and it serves about 50% of the population of the metropolitan region of São Paulo. Okay. All right. So what we observed in 2014 and 15 again was a sequence of droughts over the years, and a more severe drought in 2014. Okay. And the Canterra system was severely affected. So to give you a sense of what was going on, this is the volume of water in the different systems that supply to the city of São Paulo. The red line represents the Canterra system, the largest one. And the graph starts here in 2011. So most of the reservoirs were at about 80% of their capacity, between 80 and 90% of their capacity. And there was a sequence of dry years starting in 2013, 12, 13, and the volume of water decreased sharply. So in the beginning of 2014, when the Canterra system was operating at 30% of its capacity, actually 20% of its capacity, the local government adopted those policies that I talked about, that I mentioned. Reduction of the water pressure and use of the technical reserve started in May of 2014. If you look at the red line, at this point here, it crosses the 0. So that's the level of the reservoir. So if you're below 0, you're below the collection pipes, you're using water from the dead volume, and you have to pump the water up, okay? So the policies were implemented in January of 2014, that's the water pressure reduction. And then the use of the reservoir of the dead volume started in May of that year. And in the end of 2015, those policies were lifted. So that's the window that we're going to be working on.
Adi, we have a quick question from Santiago. I hope a clarifying question.
Sure.
Yes, I just was wondering if they change the water pressure, should not we expect like a change in the slope of the decrease of the Canterra reservoir?
That's a good question. We do not observe that. And one of the reasons why we do not observe that is that we do not know exactly. We know when they used it and when they started using it and the regions where they used it, but we do not know exactly how they did it. Did they lower the pressure to zero in some points to part of that? So it would be difficult to make that association. But if that policy was effective, we should see that. You're absolutely right. Okay. Now, the other thing that we have to think about here is that this picture here is showing you the stock of water, whereas the water pressure is dealing actually with the flow of water. Depending on the percentage of the flow of water relative to the stock, it might be a little bit difficult to see that in the data. But this is something that would be difficult to explore because we do not have the specifics of the policy, how it was used and with what intensity. But that's a very good point. Okay, so as a consequence of the crisis, there were a number of policies, both from the supply side and the demand side, that were implemented. One of the policies that were introduced was the interconnection between some supply systems. Okay, so the Canterra system was under extreme pressure, and at the time they had some infrastructure built to connect water from the Canterra system with water from other systems, and they did that at the city, not at the reservoir level. The reservoirs they occupy a very large area in different parts around São Paulo. So what they did was some of the water from Canterra reaches part of São Paulo, the water from other reservoirs reach other parts, and they interconnected these parts in the city of São Paulo. And that, of course, was a challenge to our estimation, and we had to deal with that, to our empirical strategy. As I said, there was also an increase in the use of the technical reserve, the so-called dead volume. And the term dead volume, volume morto in Portuguese, was very salient in the media, and the term itself is raises questions if you do not know what's going on in the system, if you're not an expert in water supply. So it contributes to the salience of the problem at the time. They also introduced lower water pressure to reduce water leakages and losses in some parts of the city, not all regions of the city. That's good for us in terms of our identification strategy. It also introduced a financial stimulus to encourage conservation within the Canterra system. And it also had some softer campaigns to raise awareness and ask people to promote conservation and so on and so forth. We are going to focus on these two policies here: the use of the technical reserve and the reduction of water pressure. The financial stimuli that were used were also important, but they apply to everybody in the Canterra system, whether they were submitted to lower pressure or not. And other people have been working on that, so we focus on these other two policies here. The financial stimuli were very important, actually, to promote conservation. Our outcome data, our outcome variable is hospitalization, the rate of hospitalization by fecal oral diseases. And we obtained that from the data set from the federal government. Okay? So what we have there is we have at the zip code level, the zip code level of residence of the patient, okay, not of the hospital. So we can identify the patient, the age, gender, number of days in the hospital, the main disease that led to hospitalization. So we use these variables in our identification strategy. We also have socioeconomic data coming from the Brazilian Institute of Geography and Statistics. And this is at the census tract, which is different from the zip code. To match the data from DataSUS, the health data with the socioeconomic data, we used the georeferenced maps produced by the Center Metropolitan Studies that is hosted here at my university. And we can make this mapping here, okay? In the process, we had to drop about 10% of the observations, okay? And the reason why we had to drop these observations is that, as I said up here, I think my computer is sleeping. Okay. As I said over here, some of the census tracts were interconnected after the crisis started. So we had to drop those because at one point we did not know if the water was coming from the Canterra system or from other systems. We had to drop these observations. We also had situations where a zip code encompassed a very large area. This was true for some municipalities around São Paulo. We had to drop those as well. So we dropped about 10% of the observations to make sure that we're following water that was supplied from a well-defined supply system and where we could identify a reduction in water pressure. To investigate defensive behavior and following a paper by Nidell, we also have prices of bottled water in the metropolitan region. And this data came from from FIPE, the Foundation Institute for Economic Research, also from the University of Sao Paulo. So we have our outcome variable is hospitalizations by 100,000. Okay. And the treatment variables that we have are the census tracts with pressure reduction. We obtained those from maps published by the water supply company. Census tracts supplied by water from the Canterra system, and we made sure that we only had census tracts that were supplied by the Canterra system 100% of the time. We dropped out those that were not. Again, the maps were from the water supply system. And we had some incomplete information on census tracts and zip codes. We also dropped those out. These two treatment variables allow us to explore traditional definitive specifications, but also triple differences that might help us look at some of the interesting things that were going on there. So this graph here illustrates the evolution of hospitalizations in the city of São Paulo and in the metropolitan region. And we broke that into two income groups, the low income group and the high income group. So light blue indicates census tracts where we had no reduction in the water pressure. Dark blue, those are census tracts where we do have a reduction in water pressure. And if we look to the low income group, it seems like there was a differential increase in the number of hospitalizations in the low income areas that were exposed to reduction in water pressure. Not so much so in the case of the high income group. Initially, yes, but not afterwards. And also, the graph on the left suggests, so the graph on the right might suggest defensive behavior by the rich. And the graph on the left as well, as we will argue later on, because the difference between these two reduce. So this graph is suggestive, it is provoking, and we decided to look a little bit more at what was going on. That's the sample that we use. So the darker areas are the census tract. Both dark green and dark blue are the census tracts of this metropolitan region of São Paulo that were supplied by the Canterra system. The light colors were supplied by other, or census tracts supplied by other water supply systems. If the color is blue, then we had a reduction in the water pressure. And when we say that, the best thing that we can do is we can look at the map from the company, and the map indicates the census tract where we do observe a water reduction valve. Okay, so we do not know if it was turned on or off, when exactly. We know that they announced that starting from January of 2014, they would start reducing water pressure, and we know the regions that could be affected. So there's likely a measurement error here, and the best we can do is to identify these regions with the valves and the timing of the announcement of the policy. So blue indicates water pressure reduction, or at least the regions that could be subject to water pressure reduction. Both dark blue and light blue. Light blue is outside of the Canterra region. And green indicates no water pressure reduction. Dark green in the Canterra region, light green outside of the Canterra region. The black areas were very large zip code areas that we had to drop. So heavier hospitalization was attached to a very large area, and we could not say much, so we dropped this out. And the white areas were areas where there was that were supplied by the Canterra system initially, but subsequently they were supplied by other systems as well. So we dropped this out to have a cleaner exercise. So that's our sample. A little bit on the characteristics of the sample. If you look at the Canterra region versus the region that was supplied, the regions that were supplied by other systems, the Canterra region is slightly richer, higher income per capita is slightly higher, slightly better educated, with better access to with better access to public services, so the sewage system. We also have information on the height, the topographic information in the city. The Canterra region is again also slightly older than the other regions. So these are things that we again need to pay attention to. So these are the number of census tracts in both regions, within the Canterra and outside of the Canterra region, within the pressure reduction area of influence and outside as well. Our specification. First, looking at water pressure reduction. We have a diff and diff exercise, simple classic diff and diff exercise, and an event study. So DT in this specification here is the timing of the policy. So it's a dummy variable equal to 1 after January 2014. That's when the company announced that they would start reducing the water pressure. Low press are those regions that were affected by water pressure reduction. Those are the regions where we do observe the valve to reduce water pressure. We control for the level of the reservoir that is supplying that census tract. And we have a municipality month fixed effect, a census tract fixed effect. We do a two-way clustering to account for serial correlation and spatial correlation between census tracts, and we weigh the regression by population. In our event study, again, it's the specification is similar. Nothing really different here. And we have a dummy for months before and after January of 2014. When we look at the results, we do observe an increase in the number of hospitalizations by fecal-oral diseases in the areas that were subject to low water pressure. And the increase is about 10% of the mean dependent variable. So it seems like it was a significant increase. And it seemed like it was a robust effect for the low-income groups and also for the higher income groups. But it was a much stronger effect in the case of the low-income groups. The column 4 is just a robustness exercise. Instead of looking at the rate of hospitalization by 100,000, we look at the level of hospitalization. But again, and the result seems to be quite large and significant, especially for the lower income neighborhoods. When we look at the event study, both in the case of the lower income neighborhoods and the higher income neighborhoods, after the date specifying, after the date of the policy reducing water pressure, there was a quick increase in the number of hospitalizations, in the rate of hospitalizations, followed by a decrease. So this is the effect is even stronger in the case of lower income neighborhoods. In the case of higher income neighborhoods, we also see something similar. Okay, so this might already be an indication of defensive behavior. And this is at the trimester level. So in the first trimester, we also have the same exercise at the monthly level. The graph is very similar, but of course it's noisier. This one, if anybody wants to see that, I'll be happy to share. But there, we observe an increase in hospitalizations in the first 2 trimesters and then a drop. When we look at the breakout by age groups, we find what we would expect. In lower income neighborhoods, there was an increase in hospitalizations of the very young, ages 0 to 5, and also the elderly. Okay, even though the effect is not as significant as in the case of the very young. When we look at the high income neighborhoods, again, the sign is positive. The magnitude of the coefficient is larger at the extremes, as we would expect, but they are no longer significant. I think this should be pretty clear. If anybody has any questions, please feel free to interrupt me. We also conduct a robustness check to see if other diseases, if we found anything strange with other diseases where we would not expect an increase in hospitalizations because of reduction in water pressure. And we do not find anything significant going on here. So we have vector-borne diseases, flu, neoplasms, appendicitis, and head injuries. And nothing really clear in low-income neighborhoods or higher income neighborhoods. Okay, so this is a placebo test that gives us confidence with respect to what we're finding there. Now, turning to the Canterra system. Again, we do a diff and diff exercise, but we do a simple diff and diff exercise and also a triple difference exercise. So here we have DT is the same dummy variable that we had before. It is equal to 1 after 2014. That denotes reduction in the water pressure in those specific census tracts. And we also have decant, which is a dummy variable equal to 1, starting on the date when we hit the technical reserve, the dead volume. And we do a triple difference interacting these two variables here. Again, controlling for the level of the reservoir, the month census tract effect and also a fixed effect. So when we look at the Canterra system, we see some interesting results. First, a result that we had already seen, an increase in hospitalizations due to the use of low water pressure. So columns 2 and 4, they have a triple differences specification, columns 1 and 2, double differences. So the first column, the first line, the first row shows what we had already seen, an increase in hospitalizations. But when we look at the definitive coefficient that looks at the use of the dead volume, we actually observe a drop in hospitalizations in the Canterra region. Okay. Also a drop in hospitalizations in the Canterra region post water pressure reduction, controlling for that differential already. When we do the triple differences, in the case of high income, or in the high income neighborhoods, again, there is a drop in hospitalizations. And again, the Canterra system was very salient in the media at the time. The suspicion that the water that was used from the Canterra system was contaminated might have led people to protect themselves against possible diseases that could result from the use of that water. The Canterra system was much more salient. The use of the dead volume from that system was much more salient than the policy specifying reduction in water pressure. So to further investigate that, we do two things. So we believe that this is evidence of defensive behavior. And to further investigate that, we do two things. We look at the prices of bottled water in the city of Sao Paulo, in the census tracts in the city of Sao Paulo. And so what we do is we collect data on prices of bottled water within 2 kilometers of each census tract, of the centroid of each census tract. And what we observe is an increase in the price of bottled water in the low-income areas, okay? That were supplied by the Canterra system, all right? There was also an increase in bottled water prices in the higher income area, but the magnitude was much smaller. So we're talking about 0.22 versus 0.067. And again, the mean dependent variable here is 1.93, 1.89. So it seems like lower income families have resorted to defensive behavior by purchasing bottled water. In the case of this is a little bit on a little evidence on the salience of the water, the Canterra system. So this graph here shows the number of articles in the media related to water issues in the metropolitan region of São Paulo. So we looked for the words Canterra, drought, and pressure in the major newspapers in the city of São Paulo. So this is 2014, January of 2014, when the first policies were implemented, water reduction. Oh, I'm sorry, it's right here, when we see this drop in the green line. And this is 2015, end of 2015. After that, we do not have those policies in place anymore. So there is a significant drop, it seems like, in say a significant increase in the salience of droughts in the region, especially associated with the Canterra system. So this might have explained that increase in water prices in the poor regions, but we do not see that in the richer areas of the sea. To try to investigate that, we looked at Google Trends, and we looked at some terms that might be associated with more expensive investments to protect families from the water crisis. So the lower income families, the best that they could do is to buy bottled water. The higher income families, they could actually have a bigger water tank in their houses. They could buy cisterns to capture rainwater, and they could actually build artesian wells as well. Many buildings did that. Many apartment buildings did that in the city of Sao Paulo. And so if we follow Google Trends, we see two structural breaks taking place here. They coincide with early 2014, when we see an increase in the search for these variables, for these terms here, and a decrease in late 2015 after the end of the crisis. So we take this again as evidence that the higher income families were actually defending themselves in a different way. Unfortunately, we do not have data on these prices here, water tanks, cisterns, and artesian wells. And even if we did, it would be more complicated to look at those variables because they are produced at a national level, whereas we have prices of bottled water at the very local level, at the zip code level, and census tract level in the city of São Paulo. So to check if this was not a coincidence, we also looked at Google Trends and some terms like public transportation, corruption, violence, and traffic. Those are very common topics in Brazil and in the city of São Paulo in particular. And we do not see that pattern that we saw when we estimate the endogenous structural breaks in the case of these terms related to defensive behavior and the water drought in the city of São Paulo. Okay, so these are by and Perron structural breaks estimates, and the red lines, the horizontal lines, are the confidence intervals. So to wrap it up, we investigate the health effects of the water supply policy during a very severe drought in the city of São Paulo, in the metropolitan region of São Paulo. We are expecting to see more of that this year. And we hope that with this exercise, we can learn a little bit more about policies that might have worked and that might have not worked as well, or at least some side consequences of these policies when large cities deal with extreme events, in this case, a severe drought. Again, I'm not in a position where I can do a welfare analysis and do a cost-benefit analysis of this policy. Perhaps not using those policies, not reducing the water pressure, would have a much worse situation with more hospitalizations than we did. But the idea is not to do that in this paper, but to try to see possible side consequence, side effects of these policies, and possibly anticipate those and design policies to counter them. The heterogeneity that I explore are subregions within the city of São Paulo, water pressure, and the supplying system for the different census tracts. Again, we estimate that pressure reduction has led to an increase in hospitalization due to fecal oral diseases for the very young, the elderly, and especially in lower income areas. And we also find evidence of defensive behavior with a decrease in hospitalization in the Canterra regions that were very salient in the media at the time. In the case of lower income areas, we see an increase of the price of bottled water. Those are more detailed data that we had. It can actually estimate an increase in prices. We also have the evidence from Bayan Perron on increase of search for terms that are related to investments, to higher investments on defensive behavior. And this is what I have. I hope I have not gone beyond my time.
Great. Thank you, Ari. So we now have a few minutes for questions. Santiago, go ahead.
Yes, thank you, Ari. That was a great paper. I guess I had two main comments. The first one is, I imagine that in the border of the regions with the drought, if you are next to a neighborhood that has water, I might just walk to my neighbor and ask for some water, and like I should be less affected if my neighbors have water than if I'm in the middle of the affected region that I like nobody around me has water. So I don't know if you have explored heterogeneity within the treated units that might benefit from being close to a region not that affected by the drought. And the second one, I was wondering if you have 2016 data or beyond to see if as soon as we have water, like health levels recover to before crisis, or there is some persistence because maybe now my bucket, like my elements are contaminated. So it's the impact is beyond the water crisis.
Those are excellent questions. Let me go back here to the map. I think you're probably referring to, give me 1 second. Maybe I should leave the screen. Maybe I should keep sharing the screen. I think you're talking about this map, right, Santiago? Was that your question? I think your phone is off.
Yeah, so maybe the green that I highlighted here in red can go to a neighbor that is not affected by the green here, like cannot go to a neighbor and ask for water because I like.
Right. Actually, what we have here is all of this region here has access to water. The reason why we have the white region is that we cannot identify which reservoir is supplying to that area.
No, I'm fine with that. I'm more like within the green. Sorry, within the blue. I guess I used the wrong color. Within the blue. Oh no, you don't have blue that have neighbors. Like, I'm not seeing a good example now, but within those with pressure reduction, some that can go to a neighbor that is not affected. So
right. Oh, I see. I see your point. No,
yes.
That's a good point. So if you, for example, look at the Canterra region here, and you have these borders here between green and blue. Green is not affected by water reduction. Blue is affected by water reduction. And perhaps I can just walk to my neighbor and see what was going on. That was a good question. We could try to explore these borders and see what's going on. And another thing that we could do as well is we could actually delete in another exercise, repeat the exercise that we have done and delete some of the census tract along these borders to avoid attenuation of the effect. That's a very good point. We have not thought about that. We have not done that. Thank you. The other question that you had, could you state that again?
Yeah, so if you have data on 2016 or beyond to see as soon as I get water back, like the disease go back to normal or they stay high for a while I wash and clean all my buckets. Right.
That's a very good point. And I know that for some variables, we do have information, for others, we do not. The problem, one of the major problems that we do have is that the water company announced the regions that were affected by water pressure reduction in 2014, but they have not updated the maps. So we might have data on, we definitely have data on hospitalizations, but we do not have information on water reduction. This is something that we could actually try to explore, ask the company if they would provide that. And the other thing that happened after that was that the system changed significantly. They started importing water from a different state, from the state of Rio de Janeiro, from a different water basin. And this might have affected what we have here significantly. But in any case, it would be very nice to explore the timing of these differences and see if something persisted after 2015. I do believe we would be able to do that exercise. And this could actually be very useful because I would expect a persistent effect, especially in higher income families that have invested in like cisterns or an additional water tank and so on. It's a very good point, Santiago. Thank you. I'm going to write this down here.
Alejandro, go ahead.
Thanks, Oscar. And thanks, Ari. That was a great presentation. I enjoyed it a lot. I have a quick question. I mean, this idea of the defensive behavior is, I think, pretty interesting. And you show this change in prices for water. But you have this issue that you see it for low income, but not for high income, right? And then for high income, you showed the use of other terms. But I was wondering, I mean, those terms seem to be like more for water collection or for having some water available compared to buying bottled waters, which was more related to quality, right? So I'm wondering if there's something that you could say in terms of water quality, because again, the others seem to be more related to water quantity and so I don't know your impression on that.
Excellent point. I'd love to have more, to have direct evidence on water quality. Unfortunately, we do not. I'm not even sure that we have data on water quality at the reservoir level and for all reservoirs. I know that we do have for some, but the monitoring of water quality at the pipe, at the end of the pipe, that we do not have. This is something that actually was very problematic a few months ago in the city of Rio de Janeiro, because water quality in large cities in Brazil tend to be good. You could consume that straight from the tap water. But in the city of Rio de Janeiro, in a very large portion of the city a few months ago, there was very strong evidence that something was wrong, very wrong was going on. The water was coming with a different color, bad smell, and I do not know of any monitoring of the water that is coming out, and even at the reservoir level. But in any case, I'm going to look to explore that a little more.
Right.
So the best we can do here is to make an inference to what we see is we see different policies and we see the health outcome, but do not see the in-between, which would be the water quality itself. What we do have is some laboratory evidence that the reduction in water pressure does increase contamination. But again, that's laboratory evidence. And what happens was that, so you have high pressure going within the pipes, and the system has cracks, has problems. When you reduce the pressure, you open a window for external contamination within the system. But measurements of water quality, I don't think we do have. Well, at the national level, the best that I have seen when it comes to water quality is monitoring at the national level in different parts of different rivers. There was an interesting paper that came out, I think, in 2017 at Ariaster, when they do look at the partition of municipalities and effects of evidence of externalities when it comes to pollution, but not at the city level.
Yeah, I was wondering the same thing. So just answer my question about what was the expected relation between low pressure and water quality. But I have a slightly different question too. Does the dependent variable, I mean the pressure variable, could be more quantitative? I mean, do you have some finer measurement of the pressure, maybe not the level of pressure, but how many days, or if there were blackouts, or something that would give you more detail? Because it's very different to have a pressure reduction and then have a few days without water, and maybe the effects come from those days and from not having access to water at all.
You're absolutely right, and this is the error measurement that we think we do have to live with. There is some anecdotal evidence that some parts of the city did not have any water for 2 or 3 days. The water company denied that, but people came on TV and said, please come here and open the tap to see if you find water. If you do, please let me know. And the water company did not provide that type of information. So this is a mixed capital company. A big portion of that is private capital. They are regulated by the regulator at the state level, but they keep some information very private. And your point is excellent. I mean, we do have to live with this measurement error.
Great, thanks. Mariana, go ahead.
Hello, thank you for your presentation. It's a great paper. It's not a question, I have a comment regarding your defensive behavior estimate. It seems to me that it's like a lower bound estimate of the true effect, because if people in non-treated census tract, they hear about that there is a problem with the water supply in the city, even if they don't experience any loss on pressure, they will probably buy bottled water. So I think it's very nice that you have an effect there, because you have like an intention to treat. Now that you hear that there's something wrong in the city with the water provision, so you may buy a water bottle.
You're absolutely right. That's a very good point. And I would not be surprised if that actually happened. People in different parts of the city started buying water to avoid any funny thing that might be going on within their region, even though they were not in the Canterra system. That's a good point. Thank you. It could be an underestimate of the effect. Oh, the other thing that I mentioned, that I forgot to mention, is that the data that I have here for hospitalizations are data that come from the public system. So this does not pick up any effect that might have showed up in the private system. So in that sense, it's also an underestimation of the effect. Thank you, Mariana. That's a good point.
Great. I think we are right on time. So, Natalie, one last question, I guess.
Thank you, Oscar. Hi, Ari. I was just wondering, I know you have this analysis within the metro area of Sao Paulo, but so some families here store water from the rain, right?
Yes.
Maybe this is the case in more low-income neighbors. I wonder how this seca, like how this drought that eventually led to these water supply issues may also have affected these water reservoirs, right, that each of these houses have at home, and maybe they don't use it to drink water. But yeah, I just wonder if there could be some effect there in low-income neighborhoods that could be even inflating your estimates, because they no longer have that water reservoirs either.
That's a good point. And actually do find an increase in searches for cistern. These are typically to store rainwater. Now, we would expect this to be more of we would expect this to be going on in higher income families, in higher income neighborhoods, and not so much in lower income neighborhoods. A lot of the storage of water in lower income neighborhoods would take place in informal or in water tanks that were not well treated, or buckets of water and things like that. If that was the case, one thing that we would have expected to see, but we do not find, was an increase in hospitalizations due to dengue fever. A lot of this took place during 2 summer seasons, where we do have an increase in the incidence of dengue fever. So we suspected that storing water in a way that is not, the best way with formal, with better water tanks or so on and so forth, would increase the incidence of dengue fever. Actually, there's a paper by Rodrigo Soares and colleagues that look at droughts in Northeast Brazil, storage of water in ways that were not the best ways. And what they do see is an increase in infant mortality and fecal oral diseases. And that's because these people are storing water with very poor quality. But we do not find that effect in São Paulo. Good to see you, Natalie. I think I saw you in person only once. We are in the same institution. I hope we'll have a chance to have coffee.
Hopefully.
Next door office, huh?
Yes.
All from home. Thank you, Ari.
Thank you.
Alejandro, you want to say the final words? Thanks, Ari.
Again, thanks, Ari, for a very nice presentation. Thanks, everybody, for coming to these seminars. And we see you next month. Next month, we have Alex Pfaff from Duke University will be presenting. So thank you, Ari. Nice seeing everybody.
I think there's a quick question by Maíra Bezerra. She's asking about what journal the paper was. Are you talking about what paper?
Your presentation, I guess.
No, no, this hasn't been published yet. This is work in progress. Okay. All right.
Okay. Thank you, Ari. Thank you, everybody.
Okay, thanks. Have a good day.
Thank
Bye.
you.
See you all.
Thank you, Ari, so much. Thank you, Oscar.
Bye, Jorge. Jorge, ¿estás en España?
Sí, en España. En Galicia.
Oh, excelente.
Sí. ¿Y tú, Alejandro, cuándo vas a venir?
No sé, estamos esperando todavía los trámites migratorios se están complicando un poquito, pero bueno, espero que en un par de semanas se resuelvan y quizá por ahí de mediados de octubre, yo creo. Está
Sí.
un poquito atrasado todo.
Bien.
Entre el COVID y el verano